Okay, so I'm going to go over problem number 10 on the study guide. And so here is the formula for the last non-leaf node, which is the floor of n over 2, which is n is just the length of the array, subtract 1, and this is the formula to find the left and right child. It's not really that important in terms of this problem. We don't really need it, but I think it's important to know. And so here is the array A. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm just going to write it out from left to right into a tree. The order doesn't, it's not organized yet, but we will do that afterwards. Okay, and then we have 5A, 2C, 6, 8, and 5B. Okay. And I can also label out as in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And if you look, if you compare this to our array above, it should have the same exact values. So we're going to use the last non-leaf node formula, which is the floor of n over 2, subtract 1, which is just 12, because there are 12 values over 2, subtract 1, so it's 6 subtract 1, which is equal to 5. So we will start at this one, at 3, index 5. So index 5 right here, we're going to look at its children. So 5b is a child of 3, so we just compare if 3 is greater than 5b. So the b and a in this problem, they just represent different types of satellite data, so we're not really using that. It's not that important. We don't use it to compare. What we're really comparing is just the number, 3 and 5. So what we're really asking is 3 greater than 5? It's not, so we swap them. So 5b, 3. And we're done with that. So now we can move on to index 4. And it's going to be 2b. So we look if 2b is greater than 6 and if 2b is greater than 8. So when we're doing this, because 2b isn't greater than either of them, we pick the biggest number, which is going to be 8, and we're going to swap 2b with 8. Okay, and now we can move on to index 3. So 1a. So is 1a greater than 5a, and is 1a greater than 2c? It is not greater than either or, so we pick the bigger number, which is going to be 5, so we swap 1a with 5a. And now we can look at index 2. So is 7 greater than 5b, and is 7 greater than 1b? It is, so we don't have to do anything. And now we can look at index 1. Is 4 greater than 5a, and is 4 greater than 8? It's not greater than either of them, so we pick the bigger one, which is 8, so we swap 4 with 8. And now we look at the very last index, 2a. So is 2a greater than 8, and is 2a greater than 7? Not greater than either of them, so we pick 8 because it's the bigger number. So 2a and 8. 2a, 8. So now we're looking at this graph and we got to see, well, it seems like there's this part of the problem that doesn't follow the max heap. And I forgot to say, but the reason why we were doing greater than is because this problem specifically says it's a max heap. So we want to make sure everything on top, like the root should always be bigger than the parent should always be bigger than the children in terms of number size wise. So because 2a, it's not greater than 5a or 4, we can remember when we're building this heap, it's recursive, so we can go over it again to make sure that it's following the rules of the max heap. So I'm going to erase this. And we go back to index 5. And is 5b greater than 3? Because we're looking at index 5 again. It is, so we don't have to do anything. We can go to index 4. Is 4 greater than 6? And is 4 greater than 2b? It is not. So, because 6 is greater than 4, we're going to swap them. So 4 goes here and 6 goes here. And now we can look at index 3. Is 5a greater than 1a and 2c? Yes. So now we go to index 2. Is 7 greater than 5b and 1b? It is, so we can go to index 1. Is 2a greater than 5a and 6? It is not. So we're going to swap 2a with 6 because 6 is bigger than 5. And then we look at our index 0. Is 8 greater than 6? And 7, it is perfect. And now we can look over it again, and we could see that there's another problem right here where the 2a is not greater than 4. So we can go through it again once more. So starting at index 5, 5b is greater than 3, perfect, and now we're going to index 4. So 2a is not greater than 4, so we can swap them. So 2a and 4. And now we can go to index 3. 5a is greater than 1a, and 5a is also greater than 2c. Index 2, 7 is greater than 5, 7 is greater than 1. We go to index 1, 6 is greater than 5, and 6 is greater than 4. And we go to index 0, 8 is greater than 6, and 8 is greater than 7. Now we look over it again, and it seems like it's perfect. So this should be our answer. And the question asks us to show the state of the array. So here I'm going to write out our new array, starting, because remember we have these all written out with their indexes. So index 0 is 8, and 1 is 6, 7, 5a, 4, 5b, 1b, 1a, 2c, 2a, 2b, and 3. And I'm just going to double check my answer. So we have 8, 6, 7, 5a, 4, 5b, 1b, 1a, 2c, 2a, 2b, 3, and our graph looks the exact same. So this is how you do problem number 10.